Question 2 reads as follows. The quantity of shoes produced is measured along the x-axis of a bowed outward production possibilities frontier, and the quantity of shirts produced is measured along the y-axis. As you move down towards the right along the production possibilities frontier, the marginal cost of A, a shirt increases or decreases, but we don't know for sure. B, a pair of shoes in a shirt is equal at the midpoint between the x-axis and the y-axis. C, a pair of shoes decreases. D, a pair of shoes increases. Or E, a shirt remains constant. And what our junior tutor here has written is that the correct answer is B. The marginal cost is one of the determinants of the slope of the production possibilities frontier. As we move towards the right, the slope of the PPF increases, therefore the marginal cost of producing a pair of shoes increases. So if we remember, a production possibilities frontier looks something like this, PPF. And they said along the x-axis is quantity of shoes. And along the y-axis is the quantity of shirts. Good to find that R there, quantity of shirts. So if we remember production possibilities frontier, they are bowed outward like so. And there are essentially three kinds of points in a production possibilities frontier. First is point inside. Say this point here, we'll call this A. There's a point that's on the curve, we'll call that B. And there's a point along the curve, we'll call that C. So point A, I can shrink this. So for point A here, this is an attainable allocation of goods, but it is inefficient. And that's because while you can get everything at point A, for example, we could call this like one pair of shoes and 2 shirts. You could also have 6 pairs of shoes and 2 shirts, meaning you could get more shoes without giving up any shirts. So point A is going to be attainable, but it is inefficient. Point B, a point on the line, it's going to be what we call Pareto efficient or technically efficient. They're synonyms, either works. And what that means is that you cannot have more of one quantity without giving up some of the other quantity. In other words, you've maximized the amount of research you can get from this allocation. So maybe here at point B, you can get like, call that 3 pairs of shoes and 4 shirts. And you can have more shoes. For example, if you wanted to move to point D here, you could have more shoes. So you can have 5 pairs of shoes, but as a result, you would have to give up some shirts. Say fall to 3 shirts. So both points B and D are technically efficient or Pareto efficient, they're synonyms. And basically that means you can't have more of one good without giving up any other. So point C, which is outside, is preferable. At point C, you'd probably have like 6 shirts and 4 pairs of shoes, which you'd prefer to any combination along the PPF line, but it's unattainable. We don't have the resources to have it. Preferable, but unattainable. So now that we know a little bit about a PPF, I think it's probably A little bit easier to answer the question, so I'll reread it one more time. The quantity of shoes produced is measured along the x-axis of the bowed outward production possibilities frontier, as we have here. And the quantity of shirts produced is measured along the y-axis, as we have here. As you move down towards the right on the production possibilities frontier, so for example, maybe as you move from B to D, the marginal cost of a shirt, A, increases or decreases, we don't know. B, a pair of shoes and a shirt is equal at the midpoint between the x and y axis. C, a pair of shoes decreases. D, a pair of shoes increases. And E, a shirt remains constant. And as our tutor said, the correct answer is D, that the marginal cost is the correct answer is D, a pair of shoes increases. And here's why. If you start with 0 shoes here, and you have, say, 5 shirts, all you have to give up to get 1 pair of shoes is, say, half a shirt, right? Because if you move slightly to the right from this point here, I'll call this one down here. If you move slightly to the right, you've already got 5 shirts. So all you have to give up to get 1 pair of shoes is half a shirt. But as you move further along here, say you have 6 pairs of shoes and you want more for maybe like that 6.5 pair of shoes right here, you're going to have to give up a whole shirt. So at the beginning here, all we had to do was give up half a shirt to get a pair of shoes. And at the end, if we want another pair of shoes, we're going to have to give up a whole shirt or more. And that's why the marginal cost of a pair of shoes increases, because for 1 more pair of shoes, you now have to pay more than you did when you had less pairs of shoes. I'm trying to think if there's anything else I'd like to add to that, but I think that essentially covers it. The more mathematical or scientific way to go about this, I suppose, would be if you took the slope tangent to the line at any given point, the slope would be a lot more downwards, say at this point here, or at point D, than it would be further up the curve, say at point B. So the slope of the line here, the line tangent here, that slope is way lower than the slope of the line, say, drawn there. I'll give you guys a second to take a picture of that, and then we'll move on. Excellent answer, that is correct. And we'll move on to question 3 here.